If a quadrilateral is a parallelogram, then the diagonals bisect each other is what we are going to prove here in a 2-column proof. Yes, you do. It's going to be another, like, 3. Like it was yesterday. Guys, just stop talking. All right, so the first thing is that this is a parallelogram. What do you know by the definition of a parallelogram? What did we learn yesterday we know by the definition of a parallelogram? That is not the definition of a parallelogram. Opposite sides are parallel. So, the definition of a parallel... Guys, focus, please. It's not going to take us more than probably 10 minutes to do notes today. All right, so, because of the definition of a parallelogram, opposite sides are parallel. So, that means AB is parallel to CD, and AD is parallel to BC. And that's just the definition of a parallelogram. We're trying to prove that AE and CE are congruent and DE and BE are congruent, meaning that diagonals bisect each other. So we're probably going to be proving some CP-CTC stuff again using those triangle proofs. You know, bringing that back up again because you guys loved it so much first semester. Yay. All right. So, we know that, do you guys see 4 triangles in here? Yeah, so I'm going to show you these 2. These are the 2 triangles we're trying to prove congruent, just so you guys know. So, what kind of angles are AEB and DEC? And what do you guys know about vertical angles? So we are going to say the next step here is angle AEB is congruent to angle DEC by vertical angles. There's proofs for every single shape from here on out. All right. So then we are going to use our parallel lines. So I'm going to go in yellow here with my highlighter real quick. Okay. This and this are parallel with BD as a transversal. Do you guys see that? What 2 angles are congruent based on that transversal? What 2 angles are congruent based on that transversal? Yes. CBD. Or CDB. CDB, yes. And ABD are congruent by what? No. CDB is congruent to angle ABD by alternate interior angles. Did we use that yesterday at all? Yes, we did. We did. Is 2 angles enough to prove that those triangles are congruent? No, you need 3 pieces. Can you prove triangles congruent with 3 angles? No, angle is not a congruent statement. It's a similarity statement because the triangles could just be like stretches of each other. So we need a side. What do we know about opposite sides of a parallelogram? Yes, you are right. What did you just say? Opposite sides of a parallelogram, that is a property we know, are congruent. So we have AB is congruent to DC because opposite sides of a parallelogram are congruent.
Let's go.
We are. Now, do we have enough information to prove those 2 red triangles are congruent? Do we have 3 pieces? What are our pieces? We have a... What do we have? An angle. What else do we have? Another angle and a. So that is angle, angle, side that those two triangles are congruent by. So we can say triangle ABE is congruent to triangle. So I have to follow the right thing. So the unmarked angle is C in this one. CDE by angle, angle, side. So now we can look at our CPCTC. Does DE line up with BE in our statement? Do these two line up? So that one's good. Do AE and CE line up in our statement? Yes, so those ones are also good. So that means by CPCTC, those things are congruent. So BE congruent to DE and AE congruent to CE by CPCTC. I don't know why I put by there, sorry. Could we have proven this another way? Do you see any other triangles in there? Yeah, the other two. We could have proven triangle AED congruent to, I just got to figure out which angles are lining up here. D and B need to line up, I think. So it'd be CEB. That's my initials. Yeah. Is that your initials too? No, it's not Elizabeth. It's Aaron, yes. We have done this. What's your middle name, Carmichael? Ericston? Okay. I just learned something new. Carmichael and I have the same initials. It's crazy.
Wait, what's your last name? Oh, you do?
Yeah.
Really? Miss Brady was lying the whole time.
I know. I would have this discussion with my last hour that I just like to lie to you guys because it's funny, right? Another one? Here you go. If you need something, just let me know. All right, one more. One more proof, and then you guys get your homework. So, if a quadrilateral is a parallelogram, then its same side interior angles, A and D, A and B, B and C, C and D, are supplementary. So, we start off with ABCD is a parallelogram. Okay, guys, we've discussed this before. I'm a loud person. I understand that.
People from the office can hear.
I know. It's fantastic. They know I'm always teaching. All right. We need to prove that they are supplementary this time. So being parallel isn't really necessary here. So what we're going to look at here is we know that opposite angles in a parallelogram are congruent. So we are going to say angle A is congruent to angle C. Angle D is congruent to angle B because opposite angles of a parallelogram are congruent. We proved that yesterday, didn't we? That's why we can use this. So we're trying to prove supplementary here. So we are trying to prove supplementary here. So we are going to be adding a whole bunch of things up here to get there. But first, to add things up, we need to change it to an equals. What lets us change it to an equal sign? Definition of congruence. So angle, the measure of angle A equals the measure of angle C. The measure of angle B equals the measure of angle B. you know how many degrees are in a quadrilateral? Does anybody know how many degrees are in a quadrilateral?
I do.
How many?
Wait, what's 180 plus 180?
360. Because there's two triangles. If you split it, it has two triangles, and triangles add to. So 180 and 180 is 360.
Circle was 360.
That is also true. Measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D does not fit there. 1 second. Backing it up. Back that thing up. Measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals 360 because quadrilaterals add to 360 degrees. Because life is happy. All right.
False statement.
What if you make it 4 triangles?
You do it at the least amount of triangles possible to figure that out. So for any shape you can do that, but you always have to do it with the least amount. Mm-hmm.
If I could turn
All right, please pay attention. So listen to me. Stop talking. We know that A is the same as C, and we know D is the same as B. We are going to use substitution here. We are trying to get A and D are supplementary. Do you guys see that? So which letter do we need to keep in our statement when we're doing substitution? If we're trying to get to A and D. Which letters do we need to keep? Katie? A and D, which means we're going to replace C and B because we don't want those as our answer. So from these two statements, we can say the measure of angle A plus the measure of angle B is the same as the measure of angle D. So we're going to change that to D plus the measure of angle C is the same as A plus the measure of angle D equals 360. All I did here was said that A and C are the same. So where there was a C, I replaced it with an A. Oh, I thought you were yelling at me because I was too loud again. Because it's normal. I mean, I get it.
No. Just listen for them.
I will.
They'll be fine.
All right. We know that D and B are the same. So where there's a B, we replaced it with a D. Do you guys see that there?
Yes.
So that is by substitution. So now we can combine like terms by substitution. So how many A's do we have?
2.
We have 2. And how many D's do we have? 2. And that's by substitution. And we are breathing. So then if we divide everything by 2, if we divide everything by 2, we get the measure of angle A, just 1 second, the measure of angle D. So I'm dividing everything by 2 here.
Why?
Because I'm trying to get it to be supplementary, and supplementary means 180, okay? Please stop talking. Casey, I'm trying to answer her question, but all of you are talking. So, do you see how these both have a 2 in common?
Yeah.
So I'm dividing that by 2, taking it out. But if I divide by 2 on this side, I have to divide by 2 on that side. Our goal is to get it to supplementary. Supplementary means 180. So if I take this and divide it by 2, that's just A. Take this and divide it by 2, that's just D. But if I divide 360 by 2, I get... So do you see now I have that they're supplementary because they're adding to 180? So that's why I'm doing that. So this is division. Some of you are still talking. And the definition, we know those are supplementary because that is the definition of supplementary right there. Do you guys have another proof or no?
No.
Okay, good. So, could you prove that A and B are supplementary? You're back. Good. Could you prove that A and B are supplementary? Yes, we could. And we would just be replacing different things. You would keep A and B in this statement here. Do you guys see that? Which means that wherever we see a B, or wherever we see a D, we would replace it with a B. Wherever we see a C, we would replace it with an A. You could also do the same with B and C. You just need to keep B and C in your problem that way. Does everybody see that? All right, so we are done with notes, which means you guys have the last